Welcome back to Maths with Mrs. J. We're now ready to start learning about measures of spread of a distribution. And before I teach you how to work out the variance and standard deviation, which are measures of spread, I just wanted to highlight an important fact that will become more obvious the further we go on. It's very interesting that pretty much whatever distribution you are talking about, 95% approximately of the population will sit between 2 standard deviations below the mean up to 2 standard deviations above the mean. What that looks like in terms of a graph, we have this sort of situation. Here's your mean, there's mu minus 1 standard deviation, mu minus 2 standard deviations, and here's your mu plus 1 standard deviation, mu plus 2 standard deviations. So this area under here is going to be almost all of your area. Now, obviously, I haven't drawn that very well there. It would be way closer to your x-axis there, all right? So that area is approximately 0.95, and we know our total area underneath is 1. So just bear that in mind as we look into different types of distributions. Let me just show you now how we go about actually calculating variance and standard deviation. Now, if you know how to calculate the variance, standard deviation is easy because the standard deviation is just the square root of the variance. So let me teach you how to do the variance. The computational formula that we tend to use is this here, that the variance is the expectation of x squared minus your mean squared. And remember that the expectation of x squared we find by multiplying our function by x squared and then taking that definite integral. In this particular case, this is going to work out to be between 0 and 2 of x squared times our 0.5x. Because everywhere else, the function's just 0. So what we're going to get here is 0.5 times, we're going to get x, that was x cubed, so x to the 4th on 4, from 2 down to 0, which is going to be 0.5 times 2 to the 4th is 16 on 4. And of course, that's just going to be 0. So we're going to get half of 4, which is 2. All right. This value here, we actually worked this out in a previous example, but I'll show you what it is again anyway. So this is just going to be from 0 to 2 of x times our 0.5x, which is 0.5. This is x squared, so it'll be x cubed on 3 from 2 down to 0, which is a half of 8 on 3 minus 0, which of course is 4/3. Now, when we sub it into here, what we're going to get is the variance is going to be, so variance of x is going to be 2 minus our 4/3 squared, which is 2 minus 16 on 9, which of course is 2/9. Our standard deviation is just going to be the square root of that. Let's just move over here. I've run out of room. So it's the square root of 2 over 3. We can get an approximate value for that. That's approximately 0.471. So we would know that for this distribution, approximately 95% of the results would be between your mean, which is 4/3, so 1 1/3, minus 2 of these, up to 1 1/3, plus 2 of these. All right, so that's quite interesting, and we're going to delve into that a lot more when we start talking about the normal distribution.